All right, so we are here. We're going to talk about serverless containers. I hope you all came for this. I just came in from another talk, so I really hope this is the right room. Tell me if it's not. It is not July 30th today, just to make sure you all know. It's nice and warm. We are going to talk about serverless containers, but before we talk about serverless containers, we're going to talk about this. This is what I look like when I wear a denim jacket. So my name is Martin Omander, and I was born and raised in Sweden. Some people put a tick after the O there and think I'm Irish. That's not the case. I lived in Silicon Valley for, I need to update this. It's been 20 years now. And I worked at 3 startups as a software engineer. I worked at Google for 13 years and had a bunch of different jobs within Google. But my current job, which I've had for 18 months, is that of a cloud developer advocate. So that is really two jobs in one. One is I get to go to conferences, meet awesome developers like yourselves. Thank you for coming. And hear about what things you are building. And that is my favorite part. It's so much fun to hear the cool stuff you guys are building out there. And also to help you reach further, build more by sort of standing on the shoulders of Google and on the Google Cloud Platform. Okay, that was the first job. The second job is to listen to you, those of you who are using the Google Cloud Platform, and what you like about it and what could be improved. And those of you who are not using the cloud platform, and hear about why you are not using it and what needs to be improved for you to use it. Because I meet with the product managers and the engineers who build this platform. I meet with them every week. And they keep asking me, Martin, what are developers saying in the field? Are they using our stuff? Are they not using our stuff? What are they using it for? How should we tune it and tweak it? So I would love to hear from you. And there will be a survey later on. And also, I'll stick around for a bit after this. So if you have additional questions or feedback on the cloud platform, please come and look for me. All right, so we are going to talk about pet theory. It is our case that we will follow along in this talk. This was all started by Lily, a veterinarian. She started the first pet theory clinic 12 years ago. Think back, do you have a pet? Have you taken it to a pet theory clinic? No, you haven't, because it's a company I totally made up. They don't exist. But because they're totally made up by me, there is no problem in sharing all of their code. Also, all of their code could be a lot cleaner and less involved and less hooked into other systems, and it'll be easier to understand because we're talking about a theoretical company here. Anyway, pet theory it's been going great for Lily and pet theory. They've started more and more clinics. It's become a whole chain of clinics from being just one clinic to many, many. And that has been a great journey. And now there are a bunch of clinics and hundreds of employees, thousands of clients. This is all well and good, but along the way, there has been some IT growing pains, I guess we could call them. Before, when you just had one clinic and you sort of knew all the people who came into the clinic, it didn't matter so much that customers had to call in to make appointments or to change them. Now that there are thousands and thousands of customers, they want a way to do this online. Also, there is just too many calls to deal with for the poor people answering the phones at pet theory. Also, as something grows and grows like this, veterinarians, they are passionate about treating sick cats and dogs and birds and what have you. They are not passionate about being on the phone with insurance companies, going through paperwork with insurance companies. And this has become just a crushing burden for them. Also, the receptionist, she's answering the phone all the time. She doesn't have time to send out the invoices, which is also kind of a very repetitive thing. It turns out that they have a system that creates invoices in Microsoft Word format, and that's all well and good, but it turns out not all of their customers have Microsoft Word installed, so she needs to sit there and laboriously convert them to PDFs and send them out. And then we have Patrick. Patrick. He got hired as the IT guy by Lily when there was just one clinic. You know, he doesn't have a lot of formal schooling in programming or anything like that. He was able to take care of the one PC server they had under a desk, and when they had one clinic, then it grew to 2 clinics, then 3, and then the number of machines just ballooned, and he's a little bit in over his head, frankly, here. And the systems that they had bought that ran well on one machine, now they keep crashing, customer data possibly lost. Patrick needs help. So this is where you might have heard the term software is eating the world. And this is exactly what we're seeing here. So pet theory is treating pets, right? Treating sick animals. But they're kind of a software company too. Because they need IT to work very well for them to be able to treat their pets. So Lily hires Ruby as a consultant to come in and sort out these IT growing pains. And we'll follow Ruby's journey here and see what she does. So first off, Ruby says, let's write a list. Let's invite Patrick too, by the way. Let's, the 3 of us, write a list, and we'll see how we can improve the situation. So, okay, make pet data available online. All right, so that means putting it in the cloud, up in a database in the cloud, rather than on a machine that sits under Patrick's desk. Then we have automate the sending of invoices. All right, so Lisa is spending too much time on this. Let's automate this part. And open pet data to insurance companies. So this is opening some sort of API data interchange mechanism with the insurance companies so that the highly paid veterinarians don't sit there on the phone on hold with insurance companies. Okay, these are the 3 things we'll do here. I'll show you the code, how to do these. We'll see how it works. We'll see how Ruby accomplishes this. But before we dig into this, there is a choice to be made here. There are 2 ways in which you can build modern cloud systems today. And you have to choose very early when you build a cloud system today. You have to choose one of these ways. And you might make the wrong choice. Or the wrong choice for you or your organization. You don't know until you've made it. The choice here is between the container route, it's over there, the container route, or the serverless route. Who here has used containers, Docker containers, or Kubernetes, or, oh my gosh, so many. Oh, cool, about half. Excellent. How many of you have used serverless? The same people? What? All right, excellent, excellent. So many of you at least, have been on both sides of the fence here. So a lot of this will sound very familiar to you about the advantages and disadvantages. So an advantage of these containers is, of course, you have fine-grained control, you can run anything you want, you can take your code to a different cloud provider if you want to. But some of the disadvantages here is, if you're using Kubernetes, you know that Kubernetes requires quite a bit of work to set up and care and feed. And just search Amazon for the number of Kubernetes books out there, and you'll see what I mean. Also, you will pay for idle resources. So you cannot perfectly adjust. You can try, but you never get there where you, like if you have this much load, you have this many servers, and on Monday morning you have this much load, so then you have more servers. You will always pay for idle capacity because you have to set the number of servers you have. So serverless is great because you don't manage the infrastructure like you do with Kubernetes. It's fully managed security by the cloud providers. So you don't have to deal with it. And you only pay for the usage, of course. So Monday morning, when usage goes up, you pay just for that usage. And then Monday night, it goes down, and you pay for just that low usage. However, there are some disadvantages to serverless, of course. And typically the biggest concern I hear developers say is your app is not portable. So if you don't want to do, if you don't like your cloud provider, it's kind of hard to take your code and go to someone else. You can't, also you're kind of constrained on what libraries and languages you use. So this is concerning, right? We have to choose here. And Patrick brings up a good point. Like, what if we make the wrong choice for pet theory? What if we choose containers and it turns out that we don't have the right skill set in-house to deal with Kubernetes clusters? Or what if we choose serverless and it turns out that we're not happy with our cloud provider and then we want to move our code and we're locked in? Will we get to the end of the road and discover that we've made a huge mistake here? But there's good news, because Ruby has read about some new developments in cloud computing. And what we're seeing now, we're seeing it from all the major cloud providers, although I would actually say Google is in the forefront of this. I work at Google too, so I'm allowed to say that. We're seeing serverless and containers coming together. So, of course, what that means, in an ideal, very nice world, and I'll let you be the judge of it, whether we accomplish it or not, but in an ideal world, that means that we get all the advantages of both, but we don't have to deal with the disadvantages. All right, so what does this mean? The product that does this is called Cloud Run. The Google product that does this. There are products from other cloud providers that do similar things. Although, again, taking my Google hat on, Google's is the best of them. For an unbiased view, go and talk to the others as well. So this combines both. So the first question I always get when I give this talk is, when I used to give this talk is, where does Cloud Run come from? So let's actually cast our minds back. The beginning of time, when dinosaurs roamed the earth, there was Linux. Actually, 1992. So there was Linux, right? And it's an open source project. We love that. We love open source. It means it's portable. You can download your Linux today, install it on a machine, build apps for Linux. Excellent. You have to deal with some setup, networking setup, and drivers and things like that. But you can work through all that. Or you can go to a cloud provider like Google or Microsoft or Amazon or IBM and say, hey, I want 3 Linux servers with these characteristics, and they will set everything up for you. So that is the product part here. If you go with Google, this product is called Compute Engine. So this is the bread and butter of most cloud providers today. Now, this is great if you just run a very, very simple app. You don't mind that it crashes and goes down sometimes because, yeah, maybe it's not business critical or maybe it's not that important. You have good uptime. So to fix the problems with this, another layer was created. So Google, of course, has been running hundreds of thousands of servers for a long time. So at Google, we realized we need a layer above this. Developers and operations people can't deal with individual Linux machines. There isn't enough hours in the day. So Google created containers. And Google has been running containers for 15 years. Google starts, billions of containers every week. But a few years ago, Google took this containers technology and made it an open source project, and it's called Kubernetes. And since then, it's a hugely popular open source project, so IBM, Microsoft, Amazon, all the big players have been, Oracle, so on, have been contributing to it. So it really is an industry standard. And Kubernetes sort of orchestrates your containers for you. You can say, I want 3 web servers, I want 2 database servers, here are some spare servers. If one of the web servers goes down, spin up one of these. So it is far safer to run your apps on that. And of course, you can download Kubernetes today. It's open source. Go and download it right now and install it on your cluster. Or if you don't want to have to deal with all the networking setup and all the security settings and so on, getting those right, you can just run Kubernetes engine on Google. And all major cloud providers have similar ones. The others call them differently, but Amazon does, Microsoft does, IBM does. Now, this was great, and this has been out there, Kubernetes has been out really popular for the last 5 years, maybe. There is a problem, however. Kubernetes takes a lot of time to learn and get up to speed on and become good at. And developers typically don't want to have to know about different servers and machines. As developers, I'm a developer myself. As a developer, I want to write code. Here's my business logic. Here's my data. Upload it. And somebody else, the system, whatever, figures out where it runs. So we, as developers, we don't want to deal with servers. And that is where Knative comes in. That came out about as an open source project out of Google about 18 months ago. And it has since been adopted. A bunch of other companies are contributing to Knative. And a bunch of companies have built really cool products on top of Knative. This gives you a serverless experience. So Red Hat has a great product on top of this. Pivotal has a great product. So again, you can download Knative today, right after this talk, search for Knative, download the code, install it on your cluster, and now your developers don't need to deal with servers and don't need to understand servers. They just push their code into the cluster. That is if you want to deal with all the settings, you can download and install it. If you don't want to deal with all the settings, you just run, you use the product, the Google product called Cloud Run. And as I said, Red Hat and Pivotal and others have their own products built on top of Knative. So this is where Cloud Run comes from. This is the historical perspective. You might write apps on any of these levels, perfectly legitimate reasons to do it at any level. My personal view is, if you're writing a new app, build it on the highest abstraction layer you can at first, and then drop down if you have to. But there are a lot of applications that can be written on this top abstraction layer, which means great productivity for developers. All right, so upload the data to a serverless database. Let's start with that. So here is the cloud platform, the console for this. We're looking at cloud storage. This is kind of a file storage area. Pet theory, CSV import. Okay, let's go and, oh, we have an old file lying around. We'll delete this. Let's see if I can find the right file here. Pet theory, import. Test data. So this is a CSV. Patrick is taking a CSV export from the existing customer database and uploading it. And we'll go over here and take a quick look at, oh, that's small. This is better. Import pets, test data. Ah, here we go. So as you can see, nothing strange here. It's a CSV file, so customer ID, customer name, customer phone, pet name, pet type. And here we see like Augustine Nichols, this phone number has a dog named Nicolette. So a bunch of records like this. I put them up here, uploaded it, and it should have gone into a serverless database called Firestore. Let's see there. Firestore, let's see if it took. This is always the exciting part. Did it work? Didn't it? Who knows? Oh, it did work. Okay, great. So Jonathan Yola was imported here. He has an alpaca named Domink. Okay, I guess you can have that. So now the data is up in the cloud, and we can deal with it. And what actually happened here behind the scenes is that the CSV file here was uploaded to cloud storage. A notification was sent by PubSub into an ETL app, which was written in Cloud Run, and that was pushed into the database. And the ETL app was written in Cloud Run, and ETL stands for, let's see, I always forget this one. Extract, transform, load, right. I always go into like electronic, no. Extract is the extract, transform, load. So let's double click on that and see how that app actually works. And yes? Oh, good question. So Firestore So there used to be a real-time database called Firebase. It was created by a startup, great product. Google bought that startup some 5 years ago. Firestore, I would say, is like the next version of Firebase. Taken like all of the Google resources have been used. So it, for example, has a 5 nines SLA, which Firebase didn't. You can have more complex queries, more than Firebase allowed. So yeah, next version of Firebase. How about authentication? Yep, so how about authentication was the question. In Firestore, it works very similar to Firebase. You say a node, this node can be read by these users, and you provide like a pattern of nodes that look like this can be read by these users. So for example, every user can read their own node in the big JSON tree. So if you used Firebase, it's very similar. And because you have that, by the way, great question, thank you. Because you have that authentication built into the database, these clients here can access the database directly. You don't have to write middleware that sits here. All right, so Ruby's ETL app, how does it work? What is a Cloud Run service here? Well, there are two things you need to have when you write something on top of Knative or on top of Cloud Run. The system sends HTTP calls. This is how the system communicates with your application, HTTP calls. So your application here, your Cloud Run service, your Knative service, needs to listen to HTTP calls. It needs to have like a library for that. And it needs to be stateless. So if it's stateless, where do we keep all the data? This data can potentially be thrown out between two calls. All the variables may be wiped. Well, the data, we keep that in a purpose-built database, like Firestore or Cloud Storage or something like that. And then because it runs on Google Cloud, we get all the nice logging and debugging and so on. Now, what's really cool here is that because this is stateless, that means that if your traffic goes up and it's not enough for just one server to deal with the traffic, Google can very easily just copy that thing, copy your application, and deploy it on more machines. Because it's stateless, it doesn't matter if a user first hits machine A, and then machine B, and then machine C. It doesn't matter because it's stateless. All the state is out here instead. It also means, because it's stateless, Google can spin down all of these as well, and you only pay for usage. So here you see June 1st, there was a lot of usage, paid a lot of money. June 6th, there was no usage, or under the free tier, and there was no payment. Here's a problem, yes? How do you protect your system from DOS attack? Yes, yeah, right. I mean, it used to be, right, that when you got DOS attacked, your system went down and didn't respond to anybody. In a Yes, exactly. So it used to be that if you were attacked if there was a DOS attack, your system would go down and serve nobody. In this new world, your system could potentially serve everybody, but it's attack against your wallet instead of an attack against your system availability. There are a few different things. Like there's a product called Cloud Armor, part of Google Cloud. You might want to put in front of this, or you can also set a max instances, so that you say no matter what happens, my system won't run on more than 3 servers. So then it sort of mimics the way old systems used to work. You had 3 servers, and then when there was more traffic than they could handle, the system didn't handle more requests. Possibly. Let's talk more after this. I have a few ideas, but yeah, let's dig into this after. Come and see me. Okay, so I mentioned I used to work in startups, and here's a problem that I run into all the time in startups. I would write code like this. For example, this is server-side JavaScript. It could be any language. I write code here, up here, index.js. It works great on my machine. It maybe even works great on the staging server, who knows? And then it breaks in production. And why is that? That is because the code we write as developers is often just 1 or 2% of the total code in an application. Often the 98 to 99% of code are all these other libraries that we depend on. And this was the bane of my existence when I was in startups. To have the right versions of everything here on the production server, well, same versions in development, staging, testing, production. Now, those of you who raised your hands before, you all know how to deal with this problem. How do we deal with this problem in modern systems? Containers, exactly, well done, yes. So we put this in a container, in a Docker container, for example. And this is what Cloud Run does, and Knative does. You package up your application. In the old days, you would deploy index.js and hope that everything else was there. In the new world of containers, we package everything up and deploy the whole container. So this is the difference between, say, Google Cloud Functions or functions as a service. In those cases, you only deploy this, right, and hope that it works. But in Knative, you deploy a full Docker container. But you don't have to deal with Kubernetes. You just deploy the container. All right, so here's what a Docker file might look like. I admit, I was completely new to Docker containers 6 months ago. I'm by no means an expert in them, but they're pretty darn easy. This is a container for a Node.js project. You just put up there where you import, what base image you have. And then you have your package.json, which has your dependencies and what libraries. And of course, if you use Python, there's a Python equivalent for this. What is it? Like this one is called, is it requirements.txt in Python maybe? In Java, you have like Maven things doing something, showing what libraries you have. And all of this is pulled in through a Docker file. And here is what the actual code in JavaScript might look like to import this file that we just did. Oh, what is status code 204, by the way? That's a new one. Does anybody know? We know of status code 200, okay, right? What is 204? No content, yes, well done. I had to look this up. You know more than I do. It says, okay, everything worked, but I don't have any content to give back to you. All right, so we can import CSVs into Firestore now. Now, automate the sending of invoices. All right, so now this is great. Patrick, he has been doing his research. He has found some code for this online for how to convert docx file to PDF files. Let's have a look at the script. Now, this script gives Ruby some pause. What is happening in this script? Yeah, what is happening here is it's headless LibreOffice that's being used. Sorry? Yeah. LibreOffice. It is an office suite you can download. It's written in Java, I believe. It's an open source project. It's kind of like Microsoft Word and Microsoft Excel and so on, except this is all open source software. It's a great PDF converter, by the way. It can convert pretty much any file I've thrown at it to PDFs. But LibreOffice, hey, do we have that installed? Has Google installed LibreOffice on all its servers in the cloud? Has Google installed the same LibreOffice version that we need? And of course, Patrick, he comes from more an IT ops background. He's like, hey, what's the problem with that? I install LibreOffice on the machine under my desk every day. How do we deal with this? How do we make sure that Google has LibreOffice, the right version of LibreOffice installed on the machine in the cloud? Containers, yes, very good, yes, excellent. We just put LibreOffice in here. We can put anything in a container. Containers are great. So here we go, apt-get install LibreOffice. Okay, great. Now there's LibreOffice in a container, and that code we just saw will actually work. Oh, by the way, and here we start the Python web server. It was Python code we saw before. I have no idea. That's a great question. Yeah. I don't know. How old this code is? I think this was written 6 months ago. Yeah. It runs great in the cloud. I deployed it the other day. All right, so let's run it. Let's see what happens. So here's the PDF generator, trying to run it, and who knew? Code we downloaded from Stack Overflow didn't work on the first try? Oh my gosh. All right. Let's see if there's something that can be done here. So we'll go into the log, have a look. Okay, trace back. We got a 500 back here. Is this trace? Oh, looky here. Whoa, big stack trace. Okay. So there's something about value error, cannot determine path without bucket name. Okay, something with buckets. Buckets, by the way, they're kind of like directories, but in cloud storage. Okay, something around line 43 here. Who knows what's going on? So because of that, where is it? Let's go to the debugger. So here we have the app, and line 43, oh my gosh, look here. File name, blob download, sub-process, standard out, standard error, remove, out file name, out temp file. Who wrote this stuff? Okay, line 43 broke. I don't know, there's a couple of lines before. Let's set a breakpoint there and see if that helps. So you see here, by the way, the code executed, and we got the error again. It flickered by quickly, I know. So, but it actually, the whole thing ran. Except here, it's sort of in suspended animation in the cloud. We can go in here. It's stopped on this one here. We can go in here and see all the. Here we go. We can see all the local variables. We can see the call stack, all of that good stuff, just like if you were in a local debugger. So this is actually not a real breakpoint. It's kind of a pretend breakpoint. And it would be kind of weird to call it pretend breakpoint in the UI here. So Google calls it a snapshot instead. And basically what it means is Google just takes the values of all the variables at this point and saves it so you can look at it, even though the code continued running. But it's very similar to a breakpoint. So we can see here that, out bucket name is none. What? Something's broken here. Out bucket name seems to be set here on this line. Oh, it's an environment variable. We're looking for the environment variable, output bucket. That's what's broken. All right. So we need to set that variable. Let's go in here and see. Okay. Oh, lucky me. Somebody has prepared a deployment command here. So in this deployment command, here we go. Here's the deployment command. I'll just start it. We'll deploy a new version. And here, what is going on? Oh, Cloud Run, fully managed, yes. And what region do we want to run it in? US Central? Yeah, let's do that. So what is happening in this command is we're deploying PDF gen, that's the name of the service. We're set the environment variable output bucket, the name, where to write the PDFs. We're setting that here. So whenever you deploy a container, you can set environment variables. Oh, it's done deploying. That's, by the way, is how easy it is to deploy to Knative or Cloud Run. Moment of truth. Will it work? Drum roll. It's thinking about it. Maybe, maybe not. Maybe it's a super complex file. Wrote file sample 100 KB. Oh yeah, it did work. So, so that is how you can debug these containers in the cloud in production, right? Because I don't know about you, but this always happens to me. It's like a user complains, this is broken, this doesn't work. I've run it with the same input data on my developer machine, and it works great on my developer machine. But it breaks in production. So that's why you want to debug in production. Debugging in production is a good idea if you can do it with very low overhead, which is what is happening here. Yes? Yeah, that's right. If you have different containers, different instances, this is, for you as a developer, it all looks like it runs on one machine. You don't see the various machines. You set the breakpoint, and that is activated on all the instances. And the instances, actually, so it's a good point, because the instances aren't really different because they're all stateless, right? So that means that if it breaks on server A, it will break on server B, given the same inputs. It's like kind of like functional programming in that way. Does that answer your question? Sort of. Yeah, follow up later. I'd love to talk about this stuff. This is fun. Was there another question? No? Two more questions. Excellent. Yes, sir.
How do you have multiple Docker images? Do you create private repositories? You need to create private repositories to manage it?
Yeah, that's a great question. So we create Docker images. Where do we put them? So you can put them in your own repository, or you can put them, there's a container registry component that is part of Google Cloud. And if you ask Google to build the containers for you with Cloud Build, it's called, then by default they end up in your Google Cloud project. But you can use other registries if you prefer. Yeah.
So this debugger, is that part of the Knative or is part of the Google Cloud?
This is part of, good question, is the debugger part of Knative or part of Google Cloud? It's part of Google Cloud. So if you run Knative yourself, you do not get this automatically. And this works across the different products in the Google Cloud. Yeah.
Is that language specific to debugger, or does that work across any language you're using?
Yeah, is it language specific? Yeah. So it works across, let's see, Java, Node, Python, C#, I think. Yeah, Go, of course, because however, you will find that it works slightly different ways in those languages. Like some of these languages have really good hooks into, so you can like see timing of code and things like that. I believe, is it Java maybe, that's very well instrumented, while other runtimes are not so well instrumented. So you can still set breakpoints and things, but for some languages you will get more information than others. Does it work with Ruby? I don't know. That's a good question. I'm not a Ruby programmer, so I should read up on this. I should read up on that, yeah. All right, thank you for the question. All right, debug in production. Debugging, what they used to tell you, debugging in production is bad, they were wrong. Debugging in production is great. Just make sure you have low overhead and that you don't disrupt users. All right, open pet data to insurance companies and calendar syncing apps. All right, so here we will need to, we have external systems. This is like an insurance company. REST call into REST gateway. We built that in Cloud Run, and here's the database. All right, so the code would look something like this. This is if you're using Node.js, server-side JavaScript. Who here loves server-side JavaScript? Nobody. All right. Who here dislikes or even hates JavaScript? All right, 4 more people. Yes, yes. I'm with you. I get it. I get it. It is kind of a weird language, yes. Be aware, though, that because we're running on containers, you can run pretty much any programming language you want on here. Python, C#, Java, Ruby, Go, of course. Actually, this is really exciting. I don't have slides about this, but last week I managed to get a COBOL program working on Knative. It was really cool. Yeah. Blast from the past, 60-year-old code. Thank you. And you know what what's that? It's not dead. That's right. It's not dead. And you know what my COBOL program did? It rolled "Hello World" from COBOL on the screen. I know. Yeah. All right. So here's the code. This is how you read from what's called Firestore. You have a collection, the pets collection, and you have documents in that collection, and you get the ID from the request, and you read and you return that. Boop. Very easy. Cloud Firestore is really nice to work with. NoSQL database. Oh, server-side JavaScript is starting to grow on me, Patrick says. It seems like it hasn't started to grow on any of you here, from what I can see on the show pads. But yeah, use Python, C#, whatever you want instead. All right, let's hope this works. So let's see, we'll go back here. Okay, yeah. I clicked the right link. Yes? Excellent question. So what we saw here was cold start, it's called. So this is because the container was loaded. This code hasn't run for weeks and weeks. So Google had to sort of go and rummage around, closet, find the right container, go and put it on the machine, and then, yeah. So we see a cold start time here of about 4 seconds. And if I were to reload this, it was so fast it was hardly visible, but then we get a response time of less than 100 milliseconds. So yes, when you do serverless, Cloud Functions, Amazon Lambda, what have you, there will be cold start times when your application has been down for a while. So there are various ways you can avoid that. Do as few imports as you can. Also put monitoring on your app. That's what I do, put monitoring on it, something that hits it every minute. It stays in memory. Plus, I get uptime numbers then. And that monitoring is built into Cloud, Google Cloud. It's actually called stack driver monitoring. So you can set it for like hit your service every minute or every 5 minutes. Also, actually another point about cold starts. As developers, we see cold starts all the time. And our users see it far less than we see it. So what you actually should be caring about is what is the P99 on my service? So what is the time that 99% of my users perceive? And you should look at that instead of what is the cold start time. Because there will be like maybe one user a day or one user a week or one user a month who gets a cold start. But as developers, we think cold starts are a big deal because we see it every time because we deploy a new version, boom, another cold start. Deploy a new version, boom, another cold start. So it looms large for us developers. But look at P99. If your P99 value is too low, maybe you need to do something about the cold start situation. Or maybe your P99 is good and you don't need to deal with it. Or actually what happens to me often, I find another culprit than cold starts, and I fix that to get the P99. There were questions. Yes?
What's the lifespan for the server?
What's the lifespan for one of these? It's undefined. So actually. So, Yeah. Okay, sorry, I said the wrong thing. It is undefined how long Google keeps your container around before Google puts it back in the closet. But how long can one of these run? 15 minutes. 15 minutes, 1-5. Yep. Okay, so this works. We have this. Excellent, it works. Okay, can it handle it? You all have, many of you, have a Patrick in your organization. The Patrick in your organization will say, actually, the thing you picked, the technology you picked is like Java. We all know it's slow. Or Node, JS, we know it's not scalable. Or Go, we know that it's, I don't know. We always have these doubters who want to talk about how the technology we picked isn't good enough. For some reason or other, they read some blog post somewhere. And the way to deal with the Patricks is not to get into a discussion with them, but just to run a load test. So here was a load test, 3 minutes of 600 requests per second. It was 1 minute ramp up, 1 minute ramp down. Every request generated a database read. So lots and lots of database reads here. You saw the code before. No caching or anything, and no funny business like that. It's like we do all the work all over again. So here's what happened. Google spun up this code on 85 servers, and then spun down 80 of those when the test was done. 137,000 requests came in, 0 errors. The median latency, 49 milliseconds. P99, P99, that is the value we want to know, right? 99% of users got a response within 120 milliseconds. That's the kind of value we care about. So some of these undoubtedly got cold starts, a few of these, but very few for us to get a good P99 value. Yeah? Does GCP? So this is not, there's not a load testing tool built into Google Cloud. And actually, it is my opinion that Google should not build one, because running a load test on your Google Cloud Run stuff from within the Google Cloud is kind of cheating, because you want to make sure you know also about ingress and egress into Google Cloud. There could be bottlenecks there. I mean, I know there aren't, and I can all tell you Google's networks are great, but you're not going to believe me because I work for Google. But you want to measure that ingress and egress. So this was run on loadster.com. There are lots of them external to Google. There are two numbers that we didn't pick up here that Ruby finds are even more interesting. And that is, one is that the cost of running this test, cost of handling 137,000 requests was 8 cents. And if you were to build this up with servers, just the man hours in building up the servers and configuring them would be more than 8 cents. Also, there were no engineering hours required to scale up the system. All right, we're all done. And I'm just going to skip through a few slides here. This is interesting, by the way. I'm not going to skip through this. If you run, this is Department of Energy report, don't run your own server room. Terrible idea, because you get a lot of waste. Red is waste, blue is what runs your server. Run in a hyperscale data center like Google. Also, this is 20% waste. That is what Department of Energy thinks is average for data centers. Google comes in at 11% waste. So data centers, good idea for the environment, actually. Google, okay. Yes, which one, this one? Yes. Yeah. Also, by the way, while you're taking that picture, I'll just say 11% is average across Google's, all of Google's data centers for the last 12 months. The new data centers Google is building, or the newer ones, like the one in Finland, the ones in on the West Coast here, they actually run at 8% overhead only. So the best in the industry. Google buys a lot of renewable energy. Yeah.
Google at one point played with the idea of putting servers out in the ocean so they were natural.
Yeah.
Is that really
Yeah, but so I've heard both Google and Microsoft kicking around the idea. Google has not done anything that I know of. I don't know about Microsoft. Barge, yeah, the barge. Who knows what was on the barge? Yeah, I don't know. Yeah, right. I think it gets hard to get to the servers. It gets if a power supply blows up and you have to replace it. It gets Yes. All right. Everybody's happy. Everybody gets paid. It's good. But there's one question that I have. I mean, this, after all, I've been up here for almost an hour. And I can't believe that nobody has asked me this question, given the theme of the talk. Frankly, a little disappointed in you guys. But you will get to answer it. I'm going to ask you the question. Which is better, cats or dogs? Would you please go to this link and vote? Patrick has built this application for you on the Google Cloud. We'll get to see. I don't know. Is this a dog or cat crowd? Oh, love it. You don't have to go there. Is this a dog or cat crowd?
I like cat dogs.
Cat dogs. Yeah. Also, please go to Cloud Talk, bit.ly, Cloud Talk, and fill out the survey right now. Because in 4 minutes, I'm going to have a drawing, and one of you filled out that survey will win a Google Home Mini you walk away with. Please fill that out, and I'd love to hear your feedback. And while you're all filling it out, if anybody has questions of animals or computing, yeah.
Early on, you asked for feedback on the cloud platform.
Yeah.
A little bit of feedback. So last week, I hadn't spin up Google Cloud instance simply for an interview. I was prepping for an interview, and I spun it up. And first it asked me for my credit card, and I'm like, okay, so I put it in. But then after the whole interview was done, I wanted to tear it all down. And I was able to delete the cloud instance, but it took me 2 support calls to support to get the credit card pulled out. And I had to go to Google Pay and so on and so forth. Finally, I got it out. I just lost about a half a day. My advice for you is Heroku, which I'm sure you're familiar with, has a level account, which is, they call it a hobby account. No credit cards or nothing. It's rather limited, but you can do things in there like interview prep without setting up, payments and everything else. So that's what I suggest you do is have a hobby level cloud account.
Yeah. I love that idea. And yeah, most of us in developer relations are pushing the billing people to let us do that, and hopefully we'll get there. But I think it's excellent feedback, and thank you for voicing that. Now, on Monday, I'll tell the billing people again. I was told again this. Yeah? Firebase or Firestore, yeah. Yeah, yeah.
Just to be clear, it wasn't the cost. There was actually no cost. There was like $300 per year or whatever.
Yeah.
It's just, in these days, I don't like my credit card sitting out there for no real reason.
Yep. Good points, both of you.
I have enough time keeping up with my own expenses.
Yes.
Say that randomly and generous.
I'm with you, yeah. Thank you for bringing that up. And thank you for telling us about your Firestore or possibly Firebase experience. It was Firestore. Okay, good, yeah. 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 Excellent. A little. Oh, nice. Yeah, Shaba. Yeah. Could that be when it rescales the x-axis, or is it just flaky? Yeah. Let's see. Oh, what? Cats narrowly in the lead? Oh yeah, it is going down a little, going up. Yeah, I see that. Huh. I'm very surprised to see the cats here. Usually dogs win by a comfortable margin. Okay, I'll vote for cats too. I'm going to go with the crowd. All right, so we are, anybody else wants to see this? Bit.ly, Cloud Talk. For survey, fill out the survey to be part of the drawing for this, yes. Fill out the survey. And I will start to pull up this. We'll go back. I'll just set this up real quick. right, there you are. 37 of you are on there. So this updates real time. So if you haven't had time to fill out this out yet, we'll take another minute. Any other questions?
Another comment. I
Yeah.
love to see Google really on Ruby apps. I really like Ruby apps, and I've been playing around with it a little bit, but I don't get it. There's a lot of Rails apps out there that I'd love to put out on.
Yeah. Got it. So I know a lot of people run Rails serverlessly on Cloud Run. Django and Rails, Python Django and Ruby Rails on serverlessly on Cloud Run. Something to try. Pardon?
You believe it's 100% there?
So I know we have a team that focuses on Ruby, and they say it's working now pretty well. Maybe it's a documentation thing, and they're working to get that up to speed. Yeah. Yeah. Last question, and then we'll do the drawing. Yeah.
At some point of time, I decided to convert existing infrastructure to Google platform. Can you suggest any contact with some expert or get advice?
Oh, right. So if I want to convert from Amazon to Google, is there an expert I can get help from? I don't know. I'll give you my email address, and we can talk about it. Yeah. All right. It is time. We have some more names in here. Very good. We're going to do the drawing. Now, the way it will look like I'm going over here and clicking to make it start and do mouse click. That's actually not what's happening. It's not the mouse click that's starting it. It is the drum roll from you guys that starts the wheel. So left hand, right hand, on your knees, please. A drum roll. Oh my gosh, that was loud. Who's it going to be? Srinivas, Sagarlika, Adam, Ken, Hong? Hong! It is Hong. Come on up, Hong. Thank you very much for filling out the survey, Hong. Thank you very much for your attention. I'll be around. Thank you.